Welcome viewers, in this video we'll see the solved problem based on the losses and efficiency of the DC generator, the part 2. Subscribe the channel for more videos. The soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the problem. A sun generator has a full load current of 196 ampere at 220 voltage. The stray losses are 720 watts and shunt field copper resistance is 55 ohm. The stray loss means it is nothing but mechanical, vintage and friction loss. If it has a full load efficiency of 88%, find the value of armature resistance RA. Also find the load current corresponding to maximum efficiency. So the efficiency is given, from that we need to find RA and also the load current corresponding to the maximum efficiency. Now we'll see the given data. So the load current is given 196 ampere. The voltage is given 220 voltage. Efficiency equal to 88%. The stray loss, that is mechanical and vintage loss, is 720 watts. The shunt field resistance is 55 ohm. Right? Now we'll find the value one by one. First we'll find the armature current. ISH equal to V divided by RSH, because armature current equal to IL plus ISH. In case of shunt generator, the armature current is split into load current and shunt field current. So that IA equal to IL plus ISH. The IL is given 196 ampere. ISH we can calculate from this V divided by RSH. The V is 220 divided by 55, it is 4 ampere. Right? So the ISH, the shunt field current, is 4 ampere. The load current is 196 ampere. So that armature current IA equal to IL plus ISH. 196 plus 4 equal to 200 ampere. Now we calculated the armature current. So that we can calculate the other parameters, losses, one by one. Now we will find the copper loss followed by the armature resistance. So the power output is nothing but V into IL, because terminal voltage and load current is given, so that the power output, final output, can be calculated. V into IL, 220 into 196, 43,120 watts. So this is the final output, is calculated from terminal voltage and the load current. So what is the efficiency? Is power output divided by power input. So the power output is available and also efficiency also given, so that we can calculate the power input. What is the input power? So right, we need to interchange this. So power input equal to power output divided by efficiency. Right? By rearranging that, we can calculate power input. The power output is we calculated 43,120 divided by efficiency given 88%, that is 0.88. So the power input, by simplifying that, with the power input is 49,000 watts. Right? So the power input to the DC generator is 49,000 watts. See this, the power input, the power output is lesser, because due to the mechanical friction and vintage loss, the shunt field copper loss, armature copper loss, after all the losses are available. So by subtracting the losses from the input, we are getting this much of output. Now we'll go to the losses. Now we'll find the loss. So the loss is nothing but input minus output. The input, if you subtract the output from the input, you will get the total loss. Right? 49,000 is the total input power given. So this 49,000. So the power output is 43,120. Right? So by subtracting, we are getting 5,880. 5,880 watts is the total loss. Right? 5,880 watts. Right? So the losses we calculated, total loss is calculated, but the stray loss is already given, so that we can find the shunt field copper loss. So this one, shunt field copper loss, is nothing but ISH square into RSH. So the ISH we already calculated, 4 ampere into 55. So 880 watts. So the shunt field copper loss equal to 880 watts. Right? So we know that constant loss equal to stray loss plus shunt field copper loss. Why it is called constant loss? This loss will not vary with the current, armature current. irrespective of the armature current, these two losses are always constant. This stray loss that is already given 720 watts. The sun-filled copper loss we calculated 880. These two are called a constant loss. It will not vary with the armature current. That is, it will not vary with the load. It is always constant. So, the sum of these two is 1600 watts. Right. Now, we calculated the constant loss. Right. What is the total loss? Total loss is nothing but armature copper loss and constant loss. Right. The total loss is nothing but the constant loss plus armature copper loss. But we know this total loss and constant loss, so that we can calculate copper loss. Right. From total loss, if you subtract the constant loss, we will get the armature copper loss. Right. So, the total loss is 5880 minus the constant loss is 1600 watts. So, by subtracting this, we got 4280 watts. So, this is the copper loss. Right. So, first we calculated the power input. From the efficiency, we calculated the power output. From power input and output, we calculated the total loss. Then we calculated the sun-filled copper loss. Then we calculated the constant loss, that is the sum of stray loss and sun-filled copper loss. Right. Then the total loss is nothing but constant loss plus armature copper loss. From that, we have calculated the armature copper loss. Right. But armature copper loss, one more formula available, Ia square into Ra. So that we can calculate the armature resistance. That is one of the question we need to find what is the armature resistance. Right. So, the armature copper loss, one more formula, Ia square into Ra. So, that Ra equal to armature copper loss divided by Ia square. Right. So, the armature copper loss is available 4280 divided by armature current is 200 square. So, that Ra equal to 0.107 ohm. The armature resistance is 0.107 ohm. Right. That is calculated from the one more formula, Ia square into Ra. Right. Now, we calculated the armature resistance. So, one more question, we need to find the current corresponding to the maximum efficiency. Right. So, for a maximum efficiency, one condition is available, I square Ra into equal to Wc. What is this Wc? Wc is nothing but constant loss. This is nothing but variable loss. So, the condition for maximum efficiency is variable loss equal to constant loss. This constant loss we know already is available. Right. So, from this equation we can find I equal to Wc divided by Ra, square root of Wc divided by Ra. Right. So, the Wc already available, constant loss is 1600. Ra we calculated 0.107. Right. So, here Ra equal to I square equal to Wc by Ra. So, that I equal to square root of Wc by Ra. So, these two values are substituted. By simplifying, we got 122.28 ampere. So, the current corresponding to the maximum efficiency is nothing but 122.28 ampere. So, in this problem, we calculated the power input, power output, total loss, sun-filled copper loss, then constant loss, then armature copper loss. From that, we calculated armature resistance and current for the maximum efficiency. Subscribe the channel for more videos. The soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.